Okay, now I want us to look at objects that are formed by truncations of a circle that are called segments. Now, what's a segment? Well, a segment is what you get if you take a chord and draw a chord on a circle and look at the little piece, the little crescent moon kind of piece you get by looking at the shape between the chord and the arc of the circle. In this case, it's marked in red. This is an example of a segment. Now, it's easy to get confused between a segment and a sector. So I'm going to actually share with you something that I learned a long, long time ago when I was actually in high school and I was taking geometry. My geometry teacher told a great way of remembering the difference between a segment and a sector. And you know what? It stayed with me for like a million years. Okay, I'm not a million years old, but pretty close. And here's what she said. She said, sector, it has an O in it, sector, and usually we think of the center of a circle as being sometimes using the letter O. So sector, so that means that we actually go to the center. So that's a sector. And a segment, since it has no O in it, that doesn't include the center, the origin, and so it's just that little crescent piece. And you know what? It stayed with me ever since. So maybe if you like that, you can remember it that way too. Anyway, suppose that we want to actually find the area of a segment. Well, what's the formula for it? I guess we can write one down, but it's easier to think through it. It turns out that if you think about it, this little crescent red is made up of two pieces. We take the area of the sector, which we know how to find, here's the formula for it, and then just subtract off this little piece. But that little piece is just a triangle. And we know the area of a triangle. So in fact, all we have to do to find the area of a segment is to find the area of the analogous sector and subtract off the appropriate triangle. Let's try an example and see all this stuff in action. So here I'm given a circle. I'm told this is 60 degrees, this measure of the central angle. The radius is 18. And my mission is to find the area of the red segment. And the way I'm going to do that is first find the area of the sector and then subtract off the area of the yellow triangle. Now, the area of the area of the sector is easy. So the sector BAC area is going to be easy. I just use the formula. So I see pi, now r squared is going to be 18 squared, times the appropriate ratio, which is going to be 60 degrees over 360. So that's 1/6. And so I see that this is going to be equal to 54 pi when we simplify that down. Okay, great. But now what I've got to do is I've got to now subtract off the area of that yellow triangle. Aha. Now this is going to be a little bit tricky, so let's think through this. First of all, notice that this is a radius and this is a radius, so they're both 18, which makes this triangle actually an isosceles triangle. So therefore, these two angles must be equal. And if they must be equal, then I know something. In particular, I know that since this is 60, what's left here is 120. Therefore, everything is 60. This is an equiangular triangle, which we know, therefore, is an equilateral triangle. So in fact, every single side has length 18. Now, this is a very special triangle, and we can actually analyze it to find its area. If I drop a perpendicular, since this is 18, then I know that this is a perpendicular bisector, and this is a 30-degree angle. And this here is 9. And therefore, we can either notice that we have a 30, 60, 90 right triangle, or we could actually use Pythagorean theorem. But any way you want, we can compute that this altitude, this height, is 9 square root of 3. And I'll let you do that any way you want. You might remember that, or you might actually just want to use the Pythagorean theorem and generate that yourself. Anyway, the point is we can now compute the area. It's going to be 1/2 base times height. So that's going to be what in this case? That's going to be 1/2 the base, which is 18, times the height, which is 9 square root of 3. Okay? And so what do I want to do? Well, I take this answer, that's the whole sector, and subtract off the area. So I subtract, and so what do I see? I see 54 pi minus, and this works out to be simply 81. We can see that because the 2 and the 18, when I divide, I get a 9. 9 times 9 is 81. Square root of 3. That's the exact answer. If you want an approximate answer, you can put it in a calculator and see 29.35 inches squared. And so there you can see how to find the area of a segment by taking the area of the analogous sector and subtracting off the area of the triangle.